So I will share my screen here. Awesome. All right. So here we are. We've got logs and exponents. And so let's see, the instructions here just said solve, I assume.
Yeah.
All right. So stop me if you already know it or if you're confused by something, but I'm just going to run through these because it looks like you got lots of good questions on here. So the first thing to do with this one here is to take that 1/2 and put it up to the exponent. You know that trick?
Mm-hmm.
So log base 3 of x to the 1/2 equals the log base 3 of 2 squared. You're putting this up there as well.
Okay.
And if that's true, then, well, if the log base 3 of this equals the log base 3 of that, don't just this and that equal each other?
Yeah.
So x to the 1/2 equals 2 squared. And how do I get rid of a 1/2 power? I raise it to the second power. But I got to do that to both sides. Make sense?
Yeah.
So that just equals 1. So x to the first, or x equals. So this is just 4 squared, which is 16. So 16 is your answer there.
All right.
Good.
Yeah.
This one, you remember the property of logarithms for number 5, the property of logarithms when you're adding them with the same logs with the same base, what can you do with the two?
Multiply.
Very good. So the log base 4 of x plus 3 times 2 minus x equals 1. And now you can use the equivalence. Is that what your teacher calls it? The equivalence?
Yeah, I think so.
Good. Or the definition of logarithm. So you can use equivalence. This means that 4 to this power equals this. So I'll write 4 to the first power equals x plus 3 times 2 minus x. And now to solve this, I'm going to have to FOIL this out and put this in standard form because we have a quadratic equation. Right. So let's FOIL that out. Stop me if I'm confusing you, but 2x, I'm multiplying that there, plus, minus x squared plus 6 minus 3x equals 4. Let's move everything to the left side of the equation. That way this would become a positive.
Mm-hmm.
So positive x squared, the -3 and plus 2 is a -1, but when I move it, it's a positive 1. And when I subtract 6, it's -2. Why do I want to do that? Well, because I want to solve, I want to factor and solve. So factoring this, you good with factoring?
Yeah.
X plus 2 and x minus 1.
What happened to the 4?
I added, or
okay.
I subtracted. I subtracted 6. I kind of did it in my head.
All right.
You good with that?
Yeah.
And then so x equals -2 and positive 1, but check for extraneous solutions. X equals -2 or x equals positive 1. If you go back up here, let's just make sure I'm allowed to plug in -2 and positive 1. And the reason you wouldn't be allowed to plug it in is if it gave you a 0 or a negative number inside the logarithm.
All right.
But neither of those do. Because if you plug a -2 in here, that becomes a positive 2. 2 plus 2 is 4. That works. If you plug a -2 in, that works here. And if you plug in a 1 here and a 1 here, those both give you positive numbers. So you just have 2 solutions for this.
All right.
Good?
Yep.
All right, this next problem, number 8 to the right. Notice that this is a, if I let u equal 2 to the x power, I don't know if your teacher uses this u substitution, but if I let u equal that, then this equation is really just u squared minus u minus 12 equals 0. You understand that?
Yeah.
And now this is just a quadratic, so I'm just going to solve this by factoring. This is u minus 4 and u plus 3. So u equals 4 or u equals -3. And remember, u is 2 to the x. So 2 to the x equals 4 or 2 to the x equals -3. Can you get can you raise 2 to a power such that you get a negative answer back?
No.
No, you can't. So this is what's called an extraneous solution. So I'll cross that out. So I only have to solve this one on this 2 to the x equals 4. And of course, if 2 to the x equals 4, what's x have to be?
2.
Perfect. There's your answer.
All right.
Good?
Yeah.
All right, next question. So again, you said it before. What do I do when I have a log, when I'm adding 2 logs with the same base? What can I do with them?
Multiply.
Good. So log base 3 of x plus 8 times x equals 2. And now use that same property I was talking about before. 3 to the 2 equals this. So 3 squared equals x times x plus 8. I'll just go ahead and write x squared plus 8x. That's okay with you. X squared plus 8x. So subtract 9 from both sides to get it equal to 0. Whoops, minus 9. Good. Factor. That's going to be x plus 9 and x minus 1. So x equals negative 9 or x equals positive 1. Now let's check this because we might have an extraneous solution here. Can I plug in negative 9 here for x?
Yes.
Can I? Are you allowed to plug a negative? Are you allowed to take the logarithm of a negative number?
No.
The domain of that, it's not part of the domain. So the only answer here is 1. Good. Moving on.
All right.
It seems like you're catching this. Yes, I'm not going too fast.
No.
All right. So log base 4 of x, same thing that we just did, of x times x minus 3 equals 1, which means 4 to the 1 equals x squared minus 3x. Subtract factor x minus 4, x plus 1. X equals 4 or x equals negative 1. Check your answer. That's extraneous. You can't do that. So your only answer is 4. Got it?
Yep.
What's the rule for this one?
Divide.
Good. So log base 4 of x squared. By the way, x squared minus 9 is really x plus 3, x minus 3. So I'll just write it like that. All over x plus 3 equals 3. So let's just go ahead and cancel that while we're here. So 4 to the 3 equals x minus 3. Which means 64 equals x minus 3, which means x equals 67. Boy, that seems a little high. Did I do that right, or did I go too fast on that one? 4 to the 3rd equals, no, I think that's right. I kind of want to check it to make sure that worked. That doesn't seem right to me. Something seems wrong about that to me. So we can check the answer by plugging it back in. To our graphing calculator, we could do that. Do you have a calculator that does the logarithms like that?
Not on me, no.
Log base. You have log base calculator?
I do, but not on me right now.
You do? Okay. Let me see if I can. Do you have the answer key for this one by chance?
I could see if it's up.
I have a graphing calculator on here as well, but I need to open your Jamboard so I can see it out while I do it here. I got it now. Okay, let me open my graphing calculator. And let's punch in, let's see if I've got log base. Do I have a log base? I think I do somewhere in this mode. Where is it? I don't know how to do this on this one. Well, I can do change of base on it if I wanted to. So that would be log. Let's see. see if I've got it on Desmos. See if Desmos calculator has the log base. That's easy to find.
Oh yeah, it's in functions.
It is. Oh, nice. Okay, let's just do that then. Log. Would that be miscellaneous? Oh, log A. So, oh, nice. All right, log base 4 of, and what do we say x squared? X was 67? 67 squared minus 9.
Yeah, looking at the answer key, it's 67 as well.
Oh, all right. Well, then good. It just, for some reason, it just seemed a little bit too big to me, a little weird to me. But I'll just finish it since I'm doing this so that we can see how it works. So it's this would be 70. And it is 3. How about that? All right, good, perfect. Okay, back to your questions. All right, good with all that page?
Yep.
All right, so for this one, what would we do first? Tell me what to do.
Move it all to the left. Or move the exponents.
Yeah, I would move the exponents.
All right.
I would move the exponents just because there's more than one way to do this, but I think that it's easier if you do it like this. So the log base 2 of 27 to the negative 2. Because then what can you do? You essentially do the exponentiation where you realize, oh, the log of this equals the log of that. So this equals that.
Oh,
I call it the this equals that property, since they're the same. It's really what you're doing is you're exponentiating both sides, technically. What you're doing. You're making both sides the exponent to the base 2, and that gets rid of that thing. But it's easier just to say the duh property, right? This equals that. So now for this one, I would simplify this. I would write x cubed equals 27 is 3 cubed, right? So 3 cubed to the negative 2. And then what you can do is you can swap these two, right? You understand why? You can write this as 3 to the negative 2 cubed.
Sorry, I'm lost on that.
So what I'm doing, I'm again, this is a little bit of an advanced concept here, but what I'm thinking to myself is I could write this as 3. Remember what you would do? You would multiply these together. So that would be like 3 times negative 2. But then couldn't you just switch the order of these and put the negative 2 first, like make that the first thing to apply to the 3?
Why do you want to do that?
Well, because now look what I have.
Okay.
Something cubed equals something cubed. If something cubed equals something cubed, what do you know about the sum things?
They're
the same. They're the same thing. So that's one way you could do it. To me, that was the more logical way to do it. But if that didn't make sense, you could just simplify this from this step. You can just write x cubed equals 3 to the negative 6th. And then you could take the 1/3 power of both sides to get rid of that 3. So x equals 3 to the negative 6 to the 1/3 power, because that's how you get rid of a power of 3. You follow?
Yeah.
And then you could just multiply those together and you get 3 to the negative 2. Either way is fine. It kind of, when I did this right here, in my mind, I was like, oh look, there's a 3 and there's a 3. So let's just swap these two.
Yeah.
Like that. Okay. So number 3, what am I gonna do first? Take that, move it up to here, right? What do I do with these?
Divide.
No, it's being added. So what do you do when they're added?
Oh, sorry, multiply.
So equals ln of 8, right? 2 cubed is 8. So now what?
Ooh.
Do you see how we got
you use the sorry, I forget the term.
This equals that. That's what I call it. You just say this equals that. Make sense?
Yeah.
If the both sides look the exact same, then again, you're really exponentiating both sides is what you're doing. You're making both sides the exponent for the base of e, and then those just cancel. And this equals that. Or you just say, oh, look, the natural log of this thing equals the natural log of that thing. So this thing must equal that thing.
Mm-hmm.
That's all you're doing. So now let's x squared plus 8x plus 15 equals 8. Subtract 8 from both sides. X squared plus 8x plus 7 equals 0. Factor both sides. X plus 7, x plus 1. I know I'm going fast, but it seems
No,
like
I understand.
yeah, it seems like you're pretty good at this stuff. So, and then check it. Do those both work in my problem?
No,
Which one doesn't?
neither.
Careful. You're allowed to plug a negative in as long as it doesn't give you a negative of the natural log.
So not
the one would work. The negative one would work, right? But the 7 wouldn't. Be the negative 7 because that would give you a negative log.
All right.
Make sense?
Yeah.
All right, number 9. I'm going to say, again, this equals that. So 2x plus 3 equals 9. So 2x equals 6. X equals 3. That was an easy one.
Yeah.
Oh, wow.
Yeah, that's all I got.
Well, I didn't have to go so fast. I thought you had filled up your pages. Do
I
you want to try some more? You want to try some? Get some yourself and you give it a shot?
I have more on the paper. This is from a worksheet.
Okay. You want to tell me and I'll just write it down?
Yeah. I have, did we do 13? No. Okay. Log base 9x minus 3 log base 3x equals 14.
Okay, so you tell me what to do first.
Exponents. Move the
Okay.
exponent.
So this, you mean? Up to there?
Yeah. Mm-hmm.
Good. So we've got log base 9 of x minus log base 3 of x cubed equals 14. Now what?
Can we do the this equals that yet, or do we have to?
Well, we can't. So here's the problem with this one. Do you see how the bases are different?
Hmm.
Do you see how the bases, this base and this base are different?
Yeah.
So we can't actually do those properties. What we're going to have to do is we're going to have to somehow convert this one to a base 3. That's what we're going to have to do. Or convert them. Yeah, convert that to a base 3. So do we have any properties that talk about log bases? When you have the log of base, like something to a power, like 3 squared of something, do we have some property that talks about log bases?
I'm not sure.
This is a tricky problem. Look for do you have a log property?
No.
Do you have log property? Let me see. I'm gonna look it up real quick and see. I mean, I could kind of create what property, but I'd rather just be able to look it up and find it because I know I've seen it before.
Mm-hmm.
There's something with the base. If you have a log, yeah, here it is. It's the log. So this is a good property to write down because it's one of those that you don't really see very much or use very much. But the log base a to the m times a to the n. What happens with that is you just get n over m.
All right.
That's the property. So what do I have here? I have the log base 3. This is 3 squared. Oh shoot, that actually doesn't help us in this exact instance, but there's something with this property that we can use to relate these two things together. Are you sure you wrote that problem out right?
Log base 9x minus 3 log 3x equals 14.
Log base 3.
Yeah.
So that is what it says, huh? Okay, so let me think if there's another way I can do this. Let me see. Change of base, maybe. I could do change of base, change of base.
Yeah.
So the log base A of B equals log C of B over log C of A. So I could make this, I can change this to base 3 by calling it the log base 3 of X over the log base 3 of 9. That's what I would have to do. Yep, that's what I'd have to do. And what's the log base 3 of 9? It's just 2. So there is another property. I think what the property is here, let's make it up. The log base A to the n of X equals, so what do you understand how this is just 2? So
Yeah.
that just equals 1/2 log base 3 of X. So it equals 1 over n log base A of X. Is that what we did? Mm-hmm.
So what's the one from?
That's the property that I just made up that I didn't see when I plugged it in somewhere. So the 1/2 is because this equals 2 down here. Log base 3 of 9 is just equal to 2.
Okay.
So I just pulled that one. I pulled that 2 out as a 1/2. That makes sense?
Yeah.
So my answer. So here's my. This equals 1/2 log base 3 of X minus log base 3 of X cubed equals 14. So now I can combine them together. Well, I'm going to bring the 1/2 up top now. Oh, shoot. So let's do that instead. Here, let's make this better. The formula is going to be, it's the log base A of X to the 1 over n. Right? Because you can bring that 1/2, that 1/2 up to the top of it.
Right.
You get what I'm doing there? So this equals the log base 3 of X to the 1/2 over X cubed equals 14. We good?
Yeah.
Can I keep going?
Yep.
So now let's convert that. So that means 3 to the 14 equals X to the, that would be -5/2. Oh no. -7/2. What is that? It's going to be, so I'm going to subtract these. It's X to the 1/2 minus 3, and 3 is 6. Oh, it's 5/2. Right? So that's -5/2. This is kind of a mess. So how do I solve this for X? How do I get rid of a -5/2 power? I raise both sides to
Negative.
the reciprocal, -2/5 power. Right?
Okay.
So x equals, this is a big mess. X equals 3 to the negative 28/5. Boy, that does not seem like the right problem or the right answer. Do you have the answer key for this one?
No.
That just does not seem like the correct answer.
Yeah.
I mean, we could check it by plugging it in, I suppose.
Okay.
Here, I'm gonna let this new student in as I finish this up with you. Okay. Hi there. I'm finishing up right now. We're doing honors pre-calculus. I don't know if that's what you're taking, but I figured I'd let you in. You could enjoy the show here.
Right.
Also make sure that you have your Jamboard all set with all your problems on it, because we'll get right into that in just a minute here. All right, so Eric, let's check this answer by going to, just plug it into here and let's see if we get lucky. So it's log base 9 of 3 to that power. Oh boy. 3 to the negative 28 over negative 28 divided by 5 minus I'm just going to type it in what the original was. 3 log base 3 of
X.
x, which is, what do we say it was? 3 to the negative 28 divided by 5. I'm kind of doubting that it's going to work, but let's just, oh
Yeah.
my gosh,
14, yeah.
it worked. Oh, I love it when that happens. So it worked. Perfect. There you go.
All right.
All right. So hey, I'm gonna end this this YouTube live session, and you can go check it out right there. Leba, is it Leba?
Yeah, Liba.
Liba. Okay. What class are you taking?
Honors geometry.